Good afternoon, everyone. This is Chetana HP, Assistant Professor Civil Engineering Department. I welcome you all for second session of fifth day of our 5-day webinar. This session will be on the topic light gauge steel structure, presented from the speaker Mr. Abhijit Ghosh, CEO, Techtree Consultancy Services, Kolkata. Mr. Abhijit Ghosh has acquired Bachelor of Engineering from Bengal Engineering College in 1985 for civil engineering and subsequently postgraduate certificate in general management from Indian Institute of Management IIM Calcutta in 1990. He has worked in the Braithwaite Burn and Jessop Construction Co Limited Calcutta in design, marketing, tendering, estimation, fabrication, construction, and coordination of major steel, composite, PSC rail, road bridges for more than 34 years. In 2017, he started his own organization, Techtree Consultancy Services in Kolkata, to provide consultancy in design, so proof checking of design, execution of major rail, road bridges of steel truss, steel architecture, steel plate girder, steel composite girder, PSC girder, RCC Foundation, both open on and on piles, RCC Box, Erection Cranes, Shuttering Scheme for Flyover Superstructures, civil structural work for railway electrification and other infrastructure related works. He has also have provided expertise during actual erection of 162-meter steel arch bridge at Chinalisaur, Uttarakhand. So now I would like to request Dr. C.S. Shashikumar sir, Head of Civil Engineering Department, to welcome speaker. Over to Dr. C.S. Shashikumar sir.
Sir, we are really blessed to have you on today's webinar, sir, because you have vast experience. I think that vast experience you are going to share with us, and all our participants will definitely gain good knowledge on the light gauge steel structures. So, on behalf of Vivekananda Institute of Technology, I wholeheartedly welcome you, sir, for this webinar. I also welcome Sajal Kumar Gorai sir, who is the last session speaker for this session also. Thank you, sir.
Thank
Sir
you, sir.
Abhijit, sir, you can go ahead, sir.
Yeah. Good afternoon, and thank you to you and other participants also for attending this session. Our present topic is on the light gauge steel structure. Now, since our time is not very long, so we go directly into the details of the presentations. Yeah. As you can see from the slide itself, there are two structures which are shown here. Both of those two structures are basically built with light gauge steel structure. Now, the light gauge steel structure, what this topic represents really. Gauges are basically old measuring unit for thickness, but which was originated in British iron ware industry when there was no universal unit of thickness or diameter. Light gauge here basically means the thin wall. All the walls of these sections, they are very thin, and a limit prescribed by the code IS 801, it is 12.5 millimeter. But in reality, we can see that most of the sections are built with 0.5 millimeter to 4.5 millimeter. So these are basically thin wall sections. And there is another term which is not shown in the topic itself, that is cold formed. All these structures basically formed without using any heat from those hot rolled sheets and plates. These cold form structures are basically manufactured either by press, breaking, or by rolling. Now, thin walled structure consists of a wide and growing field of engineering applications which seek efficiency in strength and cost by minimizing material. In most of the cases, we see that when we use the normal hot rolled steel sections, when the load is less or the span is less, then these heavy sections become very uneconomic. So to address those kind of situations, these thin walled structures can be used very conveniently and economically. Now, as practicing engineer, we start from the very reference we use for this kind of structure design and application. In Indian standards, there is one IS 801, that is code of practice for use of cold form light gauge structural members in general building constructions. IS 811, which gives you a lot of sections, mainly specifications for cold form light gauge structural steel sections, and IS 1079, which is basically the specification for hot rolled steel sheet and strip from which these cold form sections are manufactured. So mainly these three codes will give you a fair idea how to and what to use in these kind of structures. Now, where we can use this kind of cold form sections. Mainly, these cold form members are used in preference to the hot rolled sections in the following situations, where loads are moderate or spans are not that much, where thicker hot rolled shapes becomes uneconomical because they are heavy, so definitely their self weight is much more. So since you won't get below certain minimum sectional thickness and other specifications, so one will find that for shorter spans and lesser loads, these sections are really become uneconomical. And in certain cases, maybe a designer or user may want to use certain material which gives them, which allows them to have a very smooth surface with very fine finishing. In those events also, these kind of cold form structures can be used very economically. And there is another aspect. If we see under emergency or when time is constant for building one, say, big house or some facilities where you need to accommodate people or some other things very quickly, then for first assembly with prefabricated panel, these kind of cold from light gauge steel sections can be used very effectively because it gives you advantage over other heavy sections, because it can be handled easily, it can be erected panel by panel, you can say manufacture those panel itself in the manufacturing plant. So there are a lot of advantages when one will use these prefab panels for building and other facilities. Now we go through a few examples where these sections are already in use or they have been using. Like say building frames or roof truss, purling, girds, fascias, which are basically the frontal, or you should say the surface of the whole facility, trestles, gates, television tower, ladders, masonry base, and exposed beams and columns, where smooth surfaces are one of the requirement for the user. And then you can see various kinds of architectural, say, trusses, where the aesthetics is one of the major point these sections are definitely economically in use. And here we can see the inside of a building rather, where stairs have been used with these kind of structures, and these can be used as a formwork also for a concrete floor. This has already been used even in bridges also, where for the casting of deck panels, we can use cold formed structures to support the concrete at the time of casting. Then mechanical example where it is being used, and we know, all of us know that car trailers, boat trailers, truck, bus bodies, they are all made from wool from seeds, and but these forms are not given in definitely 811, and these are tailor made. You can use, one can use, and one can even rather desire to have in their own choice the sections made from definitely hot rolled steel plates and sheets. Now, what are the profiles and sections we have in India? What can be used? This is definitely not a exhaustive list or picture, but it gives you the basic forms which are available without much difficulty, and one can create their own form because it can be easily manufactured also. And say if we want to know about the standard length is about 6 meter. We can go up to say 7 meter or so nowadays, but plane and leaf channels and angles are mostly 6 meter long. And these structures, the requirement for these code from steel sections, we can get from IS 811. But here one user or designer can have the freedom to create their own sections by either combining say multiple sections into one by way of welding or bolting and other shapes. They can create their own shapes. Here we can see the normal channels with lip, without lip, gate sections, hat sections, box, square box, rectangular box, and these can be innovatively used as one user wants to. Then there are some sectional details, basically to give an idea. These pen channels starts with generally LC. If we go through IS 811, there are nomenclature, say LC03816, then what it means to the user. So the first three digits means 038. It gives it the web dimension, nominal web dimension. And the last two digits indicate the thickness of the material in tenths of a millimeter, means this 16 means 1.6 millimeter. So the plane channel is basically 38 millimeter of depth and having thickness of 1.6 millimeter. And we can see the how the measurement are being done even in 811s, the shear center and those other measurements have already been given and tabulated. So one can find it very useful when using the standard forms of sections. Otherwise, they have to calculate the all properties. Just wait. Sorry for disruption. What's the meaning? Hello. Here.
minimize হয়ে গেছে বলে উইন্ডোজ মিনিমাইজ হয়ে গেছে ওই জন্য হচ্ছে
All right. Sorry for disruption. In continuation, one can find all the dimensions and other details which are required.
Sir,
Either
I think PPT you need to share, sir.
okay.
It's not visible.
ঠিক আছে। Hello.
Hello, sir.
Hello. Okay. Shall I start?
Not yet visible, sir.
Oh, not visible. Okay.
stop sharing it. Stop sharing it.
Weekend problem.
No, sir, still not visible, sir.
আপনার ওটা থেকে কপি করে দিয়ে দেন এটা দেখো আচ্ছা
এটাকে দিয়ে দিই এখানে ভুলে কিছু একটা
প্রবলেম হচ্ছে ও হয় উনি আমি এখানে আসার মেইন কারণ একটা হুম
Now it is visible, sir.
Hello. Now, can you hear?
Sir, it is visible, sir.
Okay. Yes, we got.
Hello.
Hello, sir.
Uh, Now, can you give the
Yeah,
slides?
yeah, yeah, it's visible, sir.
Okay. Okay. Then shall I continue?
Please, sir, please.
Oh, okay. Thank you. So we can see the plane channels. They have certain designations. For example, LC03816, and the designation is basically gives you the idea that the depth is 38 millimeter, and the last two digits, that is 16, should be divided by 10, and that 1.6 millimeter is basically the thickness.
Sir, can you speak a little bit louder, sir?
Okay. Can you hear now?
Yeah, yeah, yes, sir.
Okay. Okay. Sorry. Uh, so, uh, just a minute. Now, this is a picture of lift channels. This is a picture of lift channels. Here, lift channels is denoted by LL, and again this first three digit, that is 064, that is 64 millimeter depth, and the last two digits, that is 25 divided by 10, that is 2.5 millimeter, that is the thickness. And here the other properties are also given in 811, which is useful for the design and other aspects for calculation and other things. Now you can see the combinations of certain basic sections. So this is nested channels, they are called. These plain channels, when you fix it by say welding, or it can be fixed in other ways also, uh, as per the demand. And then these toe to toe, this gives you a cold box section, or you can have an say plain channels back to back, then it should be welded over the top and bottom, or it can be bolted even at the web. There are lip channels, so we can have again nest formation like this. These combinations are very useful depending on the place of use and also the loading. Now, there are certain terms which we must be acquainted with when we will deal with these cold form structures. Uh, Mostly in, say, hot rolled steel sections, these kind of leaves and other things are not there. But, say, cold form sections, we get stiffened element. So what are stiffened elements? Stiffened elements are an element which is supported or stiffened by waves along its both edges parallel to the direction of stress. So it is better to see the example first. So one is stiffened compression element, like say top of the C, lift C, or the head section, top of the head section. So in the U sections has been used with a top plate, which are fixed with it. Then those becomes stiffened element. Why? Because those are stiffened by the webs. Uh, so unstiffened is, we can say, this figure 3D, which is a plain channel. Here those two flanges are not stiffened. they should be termed as unstiffened. But this wave, since this particular element is stiffened by two flanges, so this can be taken as stiffened compression element or stiffened element. Now, unstiffened element, like say an angle or a flange of a channel or even flange of a hat sections, which are only connected at one edge with the web. So those element can be termed as unstiffened. Now we have multi-stiffened elements and sub-elements, like say one hat section, but we can have two ridges or say stiffening part in the hat portion. Then we have multiple stiffened by multiple waves and stiffeners, or we can have say open channel or lift channel and then stiffened by one angle, creating two sub-element in the flange. So those can be termed as multi-stiffened element, and those element between two stiffeners, that may be wave or maybe external stiffeners. So that can be termed as sub-element. So an element that is stiffened between waves or between a wave and a stiffened edge, which are parallel to the direction of stress. So that is an sub-element. Here, one portion, or rather figure you must see, which is very meaningful, that is in the edges, that is means the flat portion where it is stiffened, it can, the stress level is very high, that is in the two's edge. But you see, when the flat portion comes, the stress level goes down, and again, where the ridge or stiffeners are there, creating the sub element, in that part, your stress level is very high. And now another term which we will find present everywhere in the code and other papers also, that is the flat width ratio. What is the flat width ratio? Flat width ratio is basically uh, W by T. It is the ratio between W, width of the flat portion. Width of the flat portion means any curvature or any stiffener, that should be excluded, and only the flat portion of the element or sub-element, and the ratio of that particular thickness of that particular sub-element or element. That ratio is called flat width ratio, and most of the formulas contain this flat width ratio, so it is very important for this cold from light gauge structure. And now another term which is definitely we find in uh, other uh, sections like hot rolled sections also, but here it is most important because of the low thickness of the sections. That is torsional flexural buckling, a mode of buckling in which compression members can bend and twist simultaneously. So bending is there, and also the twist is there. So this is very important for these thin walled sections, because most of the cases, all the strength related formulas are mainly based on this torsional flexors buckling, or to take care of this. Then point symmetric sections, about which the whole section can be called symmetric, like a Z, having equal flanges and effective design length. It is another most important, say, jargon or topic in this core form sections. It is basically a fictitious reduced width considered for design subject to a uniformly distributed stress equal to maximum edge stress. Why it is required? Because most of the cases, these sections fail by buckling, and when buckling occurs, definitely that portion which has already buckled, it cannot take further stress. So the steep portions beyond this already buckled portion, the stress goes on increasing with the increasing load. Now, since during design, we rather use uniform stress level, so the effective width generally kept reduced from the actual width, so that effective width, when multiplied by the buffer stress or the maximum edge stress, gives you the total load that can be taken by the section. So it is very important for the design aspect of this code from sections. Here, why this effective width, this concept has to be taken into account. So here a plate is there, which is basically supported in two edges, and we are going on increasing the load Q uniformly applied in other edges. Now, up to a stress where the buckling will occur at the center, that is FCR, the stress will be uniform. That is one part. And then if we go on increasing that load Q, then at the center, the stress will not go beyond FCR. It will stays like that. But at the edges where the rigidity is more, then it will take more load, and the share of stress, or rather the intensity of stress, will go on increasing. And then how long you can increase this? So that Q uh, can be increased up to a point where this stress in the edges of this particular plate will reach Fy, or the yield stress. That means that when it will reach that yield stress, it will fail by yielding. And there is one formula which is very well known to all of you. This FCR can be calculated with this expression. Now, the cold rolled steel sections are mainly produced from strip steel conforming to IS 1079, which is a code specifying hot rolled steel strip and sheet. Now, there you will find different grade of steels from 210 MPa to 360 MPa. Nowadays, even 550 MPa steels are being used to make the cold form sections. So, once this grade is known or being finalized, so the designer have this variety of choices to use this kind of steel sections. Now, how we rather mm, manufacture those cold form sections from the hot rolled steel sheet and steel. Why it is, I should say, must be known to us, because then we can know how we can even make our own sections from those basic hot rolled steel input plates. This manufacturing process is cold roll forming, either cold roll forming or press breaking. In press breaking, we generally make one mold, and by pressing the steel strip or sheet, we can get this cold form section. Or in case of cold roll forming, various rolls are there. We will see it in the next slides. And say 0 to 10 means we are at 0, taking the steel sheet or strip, and then over the rollers, we will be getting finally the lift channel with a strip in the web that is in the, say, level 10. And when we'll be cold forming this, we can even produce various kinds of forms uh, continuously. Now, how the rolling process basically appears. This rolling step from steel, so we can see as input, a strip is being fed into the series of rollers, and slowly, here we have shown only just four, but basically it's a long process, and there are various numbers of rollers, depending on the form we want to produce at final stage. So rolling stage from steel sheet to cold from steel sections, that is shown here, and here you are getting an, say, beam sections from a normal even sheet. Sheet. Now there is uh, another point which is very important for this cold from sections is when we are getting the grade of this input hot rolled steel sheet and strip, but after forming, you can see the applicable stress level can be made higher because due to cold forming process, there is a change in the microstructure of the final form section, cold form sections. And as shown in this blue picture, the effect of cold work, you can see from there, uh, the yield stress has gone up very significantly, especially at the bend, because there it is the highest, and in between definitely uh, it is below than that terminal figure, but higher than the basic raw material yield strength. So it is a positive effect of cold forming, but we have to determine from various kind of states, which is also those states are described in the code, how to determine the strength of the section. We have to determine by test the strength of the whole section, and that can be used for design also. Now, coming to the design of cold from steel structure. So mainly there are 2 points which are basically similar to our hot rolled design of hot rolled sections also, structures with hot rolled sections. So all computations for set load, stress, deflection and others shall be in accordance with conventional methods of structural design except as otherwise specified in the code, that is IS 801. So there is several provisions in the code, and according to those provisions, wherever it differs from the IS 800 and other codes, which is basically for using hot rolled steel sections, and properties of sections shall be determined in accordance with conventional methods of structural design. That means finding I, Z, and other things. We can now coming to the design stress. Basic design stress always will be taken at 0.6 Fy, that is a specified yield point. That is for bending tension, bending compression, and in tension. So if we check out clause number 6.1, it is given there. So all the formulas and other things that is one can find in IS 801. So there is no point in copying or other. Now, when the increase in steel strength resulting from cold work of forming is utilized, the basic design stress shall be Fy. F is equal to 0.60 Fy, that is average yield point of the full section, which I earlier said has to be determined from certain tests carried out on the complete section. So here we can get certain advantage over the hot rolled sections. Now, for wind, earthquake, and combined forces, stress can be increased by 33%, and corresponding increase may be applied to the allowable stresses in connections and details also. The governing clause is 6.1.2.1 of IS 801. In combined forces also that kind of increase is allowed. Um, so this is as good as we are having in conventional design with IS 800 and other codes. But now comes these rather provisions which are given in IS 801, which differs from other conventional design codes. Here, the FC is always taken in kg per centimeter square. Now, compression on unstiffened element, their FC is equal to 0.6 Fy. Till that time, the W by T is not greater than 530 by root Fy. So, this is one point we must keep it in mind when we go for design. That means we have to always check this W by T for any element of sub element which are in use, and depending on this W by T ratio, our allowable load will be determined. For W by T ratio greater than 530 by root Fy but not greater than 1210 by root Fy, there we have another expression for finding out allowable stress. And for greater than 1210 by root Fy but not greater than 25, we get another expression, that is 562,000 divided by W by T square. And now 25 to 60, there is another for angle start and for other sections, that is 1390 minus 20 W by T. But all these you will find under clause 6122 of IS 801. Now for allowable stresses in wave of beams. Now if coming to the shear stresses in wave, again here H by T is a deciding factor. What will be the allowable stress in a particular element. If it is say below 4590 by root Fy, then the expression is 1275 root Fy by H by T with a maximum of 0.4 Fy. 0.4 Fy you can relate to in IS 800 also, we can find these expressions. Uh, Now, for H by T greater than that limit, that is 4590 by root Fy, here is allowable stress is 5850,000 divided by H by T whole square. And in case of bending stress is wave, that is under clause 6.4.2 of IS 801, that stipulates that in case of bending stress, this expression should be followed. For combined stress, as usual, given means shear and bending stresses, ratios of those, that has to be used in this expression. So, in the case of design, definitely the conventional method of structural design is applicable. But at the same time, we must keep in mind that the allowable stresses are determined on the basis of the W by T. This is very vital because always the buckling check uh, that has to be carried out, and properties of sections to be computed as per conventional methods. But we have to take into account the reduced cross section or effective design width. So relevant clauses are 5.2 of IS 801 gives the designer all the provisions related to this effective design width, and calculating the effective design width, it is basically dependent on the stress level. So we have to go on certain iteration to find out that particular stress and that particular effective width. So this portion of total weight to be deducted from the central line of the element. তাহলে how this reduce width means something has to be deducted from the actual width. So that deduction or deducted width must be in the center line. So if the effective width is B effective, then half of B effective should go to one edge, and at the other edge, that half of B by 2, B effective by 2 should go. Now, there are certain formulas which are basically used for B by T determination. So when it's a question of determining the strength, so effective design with a compression element up to W by T limit is 1435 by root F. Up to that limit, effective width is actual width. So B is W. But when it goes beyond that, when W by T definitely more than W by T limiting, then that expression is d by t is equal to 120 by root f 1 minus 465 divided by w by t again square root of f. So f is basically the actual stress in the element. Now this w by t is dependent on the actual stress itself. So we need to recalculate, means we have to find out a point where our this assumed stress level and the effective width this come at a certain point when it will match each other. Rather, we have to do certain iteration before arriving at the effective width. So for closed section we definitely have certain increase in that up to 1540 by root f v is equal to w, and beyond that limit again another expressions is there. Now for deflection, basically for deflection uh, uh, higher sectional properties is allowed, or rather here the effective width is more, we are getting more effective width which can be seen from the expression itself. For calculation of deflection, which is comes under uh, 5.2.1.1. Here, the effective design width for compression element up to W by T limit is 1850 divided by square root F. So, up to that point, we get V is equal to W, which is definitely more than whatever we used in the case of load determination, calculation of strength. Uh, again, when W by T is more than this W by T limit, then we have this expression d by t is equal to 2710 by root f multiplied by 1 minus 600 by something W by t root f. So if we see, though the expression is in a similar nature, but the figures are different because in case of deflection, we are allowing more effectively, but in case of strength calculations, our effective weight is definitely in a conservative side due to certain factor of safety aspect. Now, again for deflection determination for closed section, another expression in the code. The clause is given there 5211. Now, the little bit of explanation possibly is required here. A stiffener is definitely not an wave. It cannot
Now, normal stress. Now, how do say get the normal stress in the flange? Get, I think there is certain disruption due to some issues here. Hello. Okay. Okay. Um, so waves, they are not basically a shear bearing element. Waves are shear bearing element, but the stiffeners are not shear bearing element. So the wave, when they are basically causing the normal stress to the flanges, a stiffener definitely will not behave in the same way. And that is the reason if you see a black, the stiffener cannot be a element which can replace a wave. So now when A stiffeners are used, what is a stiffness? It's basically a flat compression element, maybe considered a stiffened compression element which have the following minimum moment of inertia. This moment of inertia calculation is given in clause 5.2.2 of IS 801. Uh, you can see the expression from the code itself. Here also it is given. But main thing is that intermediate stiffness basically provides stiffness to a single element, to element to its left and right. But if we see an edge stiffener, it provides stiffness to an element to one of its sides, and the due to that, the required stiffness of an intermediate stiffener is basically double than the A stiffness. So this point is not similar for the stiffness we use in hot rolled steel sections. So this point is unique here and must be taken care of during the design. Now, maximum allowable weight depth. So there are provisions which limits the depth of an web uh, depending on its thickness. So if it is unstiffened, if the web is unstiffened, so H by T max, the limit is 150, and members which are provided with adequate means of transmitting concentrated load, that means stiffness and other things. There, this limit is increased to 200. And in case of H, it is the clear distance between flanges measured along the plane of the wave, and T is the wave thickness. Always one thing to be kept in mind, if there are multiple seats in making a wave, then but H by T ratio shall be computed for seat only, because this may be in a single seat. So this is also covered clause 522 of ISA 801. Now utilization of cold work of form. So available allowable stresses shall be based upon the specified minimum properties of the unformed steel, that means the raw steel which will be using in producing the cold form sections, and utilization for design purposes of any increase in steel strength that results from a cold forming operation is permissible provided that the method and some limitations and observed and satisfied. Means we have to carry out the tests on the full sections as per the provisions given in the IS 801 to determining the average yield stress in the final from sections. So there we can use our advantage the higher stress which has been developed due to the cold forming of the sections. And another important aspect of these cold form sections is the wave crippling, which is not always visible in hot rolled sections because the thickness of those sections are quite more. So to avoid crippling of unreinforced beam, it's having a flat specificity equal to or less than 180. So code has given limit uh, for this concentrated load and reactions under clause 6.5 just to avoid the occurrence of crippling in a uncertain way. So in this slide, these have been given. We need not to go through into the details right now. It can be seen in the code afterwards also. But mainly the end reactions and the concentrated load on outer ends of cantilever, there is one expressions. What is the maximum load which can be given at a particular point, or what is the maximum reaction that can be taken in a particular point. And then the reactions of interior supports, if there is an interior support or any concentrated load located on the span, means not in the cantilever. So there is another expressions for the maximum under these conditions in the code. Yeah. And for again I-beams, if that I-beam is made out of two channels connected back to back, then end reactions are given by the expression P max equal to D by multiplied by 4.4 plus 0.558 minus n by T. And again, interior supports and concentrated load in this kind of beams that is also given in code. So the meanings and other things that are shown here, since you will be knowing all these things, so I'm not going to do anything over that. Now comes the connection. How do we connect these board from sections with thin wall sections? Connections are designed to transmit the maximum stress in the connected member. We can connect it by weld. Most of the cases, fusion welds, and those are sports welds also. We can see most of the sports welds are being used in the manufacturing of cars and other things. They are getting used in the trains, ships also. Sports welding can be done very quickly in an automatic manner, so it's a preferred method and very effective also. Uh, Another connections, way of connection of bolt connection, but the point which I want to stress, since the thickness is very thin, the shear and other failures is very much there.
Sir, you can continue, sir.
Oh, thank you. So, in this bolted connection, we can see spacing shall not be less than 1.5 T, and it should not be less than also P by 0.6 FYT also. This P by 0.6 FYT is not generally used in the hot roll sections, but here it is important and has to be taken care of. And tension stress, as usual, has to be checked on the next section. and it should not exceed the expression of 1 minus 0.9 r 3 r d by s multiplied by 0.6 fy. Terms are given. R is the force transmitted by the bolt and is spacing of bolts perpendicular to line of stress. Uh, now we come to analysis and design using Stat Pro, which are definitely a tool which are being used by younger generations and today's students and maybe the future designers, uh, because manual designing has mostly been stopped for all the youngsters. Now, in case of Stat Pro, the modeling of structure can be done with this code from sections because it is already included in the softwares like StatPro. So during modeling part, if we go to the property menu and select code from steel, you will find there are lots of sections which are already included in the StatPro. So you can use these sections in say modeling the structure as you like, and the design can also be done with StatPro under the provisions of this code. In the design menu, we have to select the steel design and then the current code which should be selected as IS801. So by using these comments, you can form your own structure with this code from sections and also the design with the provisions of IS801. And now come to the last, but definitely the most important thing of any structure, because ultimately it has to be used somewhere. So that means we have to erect, assemble, and erect the structure to give the final shape of it. Now, erection with light gauge steel structure basically demand a very keen eye on the detailing part, because if we do not keep an eye on detailing, definitely it's going to fail during the erection. Here one example has been given for say one, uh, you see the workshop structure. So first is we have to prepare equipment, material, everything, and we have to stack it safely so that no damage is done to the thin wall structures. And first we have to erect the columns which has already been assembled as a whole, because those columns are basically not very heavy. It is an advantage of structures, say, done with the code from sections. And now then we have to erect the raptor, uh, and then we are, but one can see that during the erection of raptor, the say fixing of slings on that particular structure is very important, and also we cannot use very hard cables or wires with these sections. It is preferred to use the nylon based or polypropylene based slings, which will not damage the structure or the paint on it. And the, we have to create the purlin braces and then frame by frame to complete the structure. But one thing for erection, we must keep it in mind that no damage is done to the section itself, because it is very thin and cannot take impact of, with too much heavy handling. Now the advantage of these structures, you can see buildability, because you can use your own sections, you can use it the way you want. It is very light, so definitely the being the self weight is low. Your supporting structures like foundation, other things, that becomes very light also. Strength, definitely you already have seen that due to cold forming you can get advantage of certain higher yield strength. Design flexibility, so you can have a variety of choices. speed of constructions because you can make sub assemblies in the shop itself and can use it at one go, panel by panel. Structural safety, in the lightweight, quality, definitely most of the things are done in workshop, so the quality standard can be maintained better than when we are basically doing lot of things at site. And remodeled because it is light, and remodeling can be done very easily, and recyclable because it is steel. Now there are certain disadvantages also. Uh, Steel is definitely non-combustible material, but at the same time, when it goes at certain, the temperature goes at certain level, it start to definitely uh, a little bit of stage before it, not always molten state, but before that it will have a yield, some sort of yield, or hello. Huh. So a coating of paint which can resist fire so that it gives you enough time to get out of the covered structure, that is very much required. So a protection from fire, it's a very big issue for any structure which will use these cold form structures, cold form sections. And then another point, which is basically from the user's point of view, that is light frame structures allow passage of sound, which is undesirable in many cases, like say in a studio or in say where you can use say different kind of things. Uh, so where you edit cinemas and other things. So in that event, you have to use soundproofing and other thermal insulations, which is normally done for these kind of structures. So I think this is the last of it, and with it, I will say thank you for give patient hearing to these presentations, and wish you best of luck in future. Thank you.
Sir, thank you so much, sir, for your highly informative lecture. Sir, I think we have few questions. Can we take up, sir?
Yes.
Sir, I have one or two questions, personal questions. Sir, you said we can weld the late gauge sections. They are so thin. Is it really possible, sir? How do they?
Uh, 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 there is a disruption. Will you please repeat the question?
Yes, sir. Sir, you said to create a box section, they are going to weld both two light gauge sections. They are so thin, like 1 mm, 1.5 mm, 1.6 mm. How do they really weld it?
Sir, please continue.
Yeah. Please unmute, sir. Sir, my question is,
Yeah.
to create box sections, we need two sections and we have to weld them.
Yeah.
They are so thin that it is 1 mm or 1.5, 1.6 mm.
Yeah.
How do they really weld them?
No, in that event, your say welding is also done in that way. It is suitable for these light sections only. If we apply those kind of welding in our normal hot roll sections, possibly it will not have any effect. But for these thin rolled sections, those welds are effective enough to join the two members. And spot welds are definitely very useful when you join back to back, but when you face to face join, say, two flanges, definitely different kind of welding has to be adopted.
Okay, sir. And sir, using the what is the construction stage in India, sir, are we? I mean, there are ample number of construction happening using
I
co-form
should not
structures.
say no. I should not say ample number because definitely that kind of data is not available. But most of the cases we will see in airports, in fascias and other sections, though pulled from structure, definitely in use. And nowadays, say in case of deck casting, there are a lot of pulled from structures which are being used as a supporting structure for casting of decks in bridges.
So, and also the design code has not been revised. I
Yeah,
think it
that
is
is
still
yeah,
in
yeah. That is an
working stress
issue.
method.
But whatever I have gathered, that it is under consideration and the work is being in progress, possibly under the guidance of IIT Madras.
Okay, sir. Okay, sir. I think Chetana, can you take up the questions? Uh, are there any questions, Chetana? Hello, Chetana.
Yes, sir. Actually,
Uh,
questions will be taken by Siddharaju, sir.
okay, okay.
Can I?
Sindraju, please, can you please go ahead? Sidraju,
I think he is not in the like.
you only please carry on with the question and answer session.
Yes, sir, just a second. Hello.
Hello.
Hello. Sir. Sir, as of now, there are no questions. So, like, we are asking the participants to give the questions. So, if they post the questions, then we will directly contact you,
Okay,
sir, so
okay,
that
okay,
we'll get the
okay,
answer.
okay. I think, sir, there are no further questions. And, sir, I think you have given us complete details of the code formed sections and its applicability. On behalf of management and students and staff of Vivekananda Institute of Technology, I wholeheartedly thank you, sir, for giving such a wonderful information. Thank you
Uh,
so much, sir.
yeah, thank you also for giving me the definitely I got a pleasure to definitely present this paper to you and getting this chance. Thank you again.
1 minute, sir. Sir, Samantha, sir, is there?
Yeah,
Samantha, sir,
yeah,
your
sir.
final remarks.
Yeah, today I must thank Mr. Ghosh to make it happen. Unfortunately, I am out from Kolkata, and here also I am attending one program. As you can listen, that sounds are coming. But anyway, I will speak less. Rather, I will listen everything. So, sir, I think you go ahead with your valedictory session. I am here.
Okay, sir.
And I must especially thank Mr. Ghosh because in my absence, my friend Mr. Sajal Kumar Ghoda, he might have taken care of him.
Yes, sir.
So
Yes, sir.
anyway, I thanks all of you. Okay, Mr. Ghosh,
Oh,
thank you. But
yeah.
you remain online for concluding session. Okay,
Okay.
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 Yes, sir. Thank you, sir. Chaitanya, can we start with the program?
Yes, sir. Yes, sir. So, good afternoon, everyone. So, I welcome you all for the validatory program of our 5-day webinar. Now, we are at the ending of webinar. It was great, informative 10 sessions of webinar with speakers presenting with immense knowledge in their respective fields. So, I request Dr. C. Shashikumar, sir, to welcome all the dignitaries to the program and also read out the brief report of webinar.
Thank you, Chaitanya. As you said, we have come to the fag end of the program. The 5-day webinar was successful. Yes, definitely we had a problem the first day. Then later on, I think because of the help of our organizing secretary, Mr. Harish, we could able to bounce back. I should thank him for his support. Uh, On behalf of Vivekananda Institute of Technology, I welcome today's chief guest, Engineer Mohan Rao, to this valedictory function. I also welcome Mrs. Indira Gopalakrishna, who is also one of the chief guests of this session. I welcome you, madam.
Thank you, sir. It is a
I
great honor to
welcome.
be with you.
Sir, good
I'm
afternoon.
honored to
I
be
also
become
welcome
part
you.
of the webinar.
Thank you, ma'am. I also welcome guest of honor A.K. Samantha sir to this valedictory function. I welcome advisor come administrator of Vivekananda Institute of Technology, Dr. Govindaraju, to this valedictory function. I also welcome our principal. All of you, I request all of you to please go on mute. There is a double voice. It is coming. Can you please go on mute? I would like to thank our principal, Dr. Padmanabha S, for his support throughout the webinar. I also welcome Vice Principal, Dr. D.V. Chandrasekhar, for his cooperation throughout this webinar. Uh, and I welcome all our staff and students of Vivekananda Institute of Technology and the participants to this valedictory function. I want to tell one thing in this scenario that this program was not at all planned actually. Once there was a discussion with Dr. Engineer Mohan Rao sir regarding some technical issues, and then he said about INSDAG to me, and I had earlier read so many articles from the which were published from the INSTAG. Then that forced me to actually go for a webinar with INSTAG, and it happened mainly because of Engineer Mohan Rao sir. And then he gave the contact of Samantha, Dr. A.K. Samantha. He really cooperated in from point to point. I think the in the entire webinar, he took the initiative more than us. I think the more pain has been taken by Mr. A.K. Samantha. Then we both together choose the topics which were very relevant to the field as well as that is to the field engineers as well as to the students. And the first session was an overview by A.K. Samantha sir, and the second session was regarding this pre-engineered building design and construction by Mr. S. Chanda, who is the senior manager of INSDAG. And again, case studies on pre-engineered buildings was delivered by Mr. N. Basu, who is the CEO of Basu Consultants, Kolkata. And again, the fabrication of steel was delivered by Samantha sir. Then scope of automation was also taken up, and which was delivered by Abhilash Joseph from Aviva Groups, Mumbai. And and the life cycle assessment was delivered by again A.K. Samantha sir. Then high-rise building construction was delivered by S.H. Jain, who has built really high-rise structures to about 100 meters. That was his, I mean, 100 floors in fact. He is the CEO of Struck Bombay Consultants, Mumbai. And today we had a design and analysis and design of steel structures using STAD Pro by Mr. S. Gorai, who is also the manager of INSTAG. And the final lecture was delivered by Mr. A. Ghosh, which is on the light gauge steel structures. He is also the CEO of Techtree Consultancy Services, Kolkata. So, on behalf of VKIT, I thank who have supported, who have delivered the lecture, and really participants have given us the feedback. From that itself, we have come to know that it is really a successful one. And there are around 1,000 participants have participated in this webinar. From India, if we take from Karnataka, we have around 186 participants. From Tamil Nadu, it is around 62. Then Andhra Pradesh, 18. Then we have Telangana, 26. West Bengal, 11. And from other parts, around 717 participants from India itself. And surprisingly, we have students from Philippines who have, there are around 223 registered participants, and they have success every day they have attended, and that shows really the importance of this topic. And also from Afghanistan, we have around five participants. From Myanmar, around 10, and Bangladesh, around 8. I think all these in the participants from other countries is mainly due to, I think, the support by Dr. Santosh from JSS College of Engineering, and also I should thank Mr. PL Shashidhara, who is the treasurer of the ACC India Bangalore Center, and along with the INSDAG. I think they have supported in getting all the international participants. That is how I think this program is a successful one, and I think the lectures have really motivated them, and they have told us to actually. I mean, the participants have told us to again organize this kind of programs with some other team in association with INSTAG. I think on behalf of Vivekananda Institute of Technology, I thank all the participants and all those who have really helped us in successful completion of this webinar. Over to Chetana. Chetana?
Chetana has muted our speaker.
Yeah.
Am I
Chetana,
audible,
are you
Professor?
there? Yes, sir, you are audible, sir. Chetana, are you there? It's okay then. Now we have.
Now I would like to introduce our chief guest, Engineer K.L. Mohan Rao, sir. So he is a mechanical engineering graduate with a PG diploma in HR, is an esteemed member of BAI, and is associated with work for institutions and organizations such as HAL, NAL, LRDE, ADE, Tata Institute, Central Exercise, BEML, ITI, BEML Corporate Office. Hello? Sir,
Yes, Chetana.
Can you listen me?
Yeah. You are audible, you are clear, no issue, Chetana. Go ahead.
Hello.
Yeah, Chetana, you can go ahead. We could listen. We could hear you.
Hello, sir. Am I audible?
Yeah,
yes.
Yeah, you are audible. Please go ahead.
Hello.
Hello, Chetana, you are audible. Please go ahead.
Hello. So, am I audible?
Chetana. Yes, Chetana, you are audible.
Hello.
I am at a very remote place. I am able to hear you.
I think there is some issues with her internet
am I audible
connection.
now?
Yeah, you are audible. Please go ahead.
Just a second. Hello.
Yes, Chetana, please go ahead.
Sir, thank you. Sir, I was just introducing our chief guest. So, he has been an entrepreneur for 35 years, specializing in computer room, sound and thermal insulation, etc. He has been working in the field of training since 2002 and is the founder of Kaushalya Shale and founder principal of Bangalore Metro Rail Training Institute from 2011 to 2017. With a passion for working closely with the youth, he is presently carrying out assessment of the trained workforce by the welfare board throughout Karnataka through Builders Association India Bangalore Center. So now I would like to request Engineer K.L. Mohan Rao sir to address the gathering and release the souvenir of like a e-copy of our technical webinar.
First, I would like Engineer Mohan Rao sir to release the souvenir first, and then you can continue your talk, sir. It will be released by sharing the e-copy on the screen.
Good evening.
Good evening, sir.
Sir, it's a pleasure sharing this beautiful event by VIVEKANANDA Institute, and I
INSDAG.
I am happy to release this souvenir on behalf of VIVEKANANDA Institute for the benefit of the students and the working professionals, I can say, throughout the world now, after listening to the attendance. So I think I have never addressed such a big gathering anywhere in my last 25 years of experience. Thank you for giving me this opportunity.
Sir, can you please scroll a few pages?
So it is talking about all the people who are part of this program, about INSDAG, about SIDA, JES, KVIT, organizing committee, and a lot of the speakers' profile is there, and nearly 258 pages are there. I think all the presentations made in the 10 lectures in the last 5 days is present there. And the idea of giving this presentation here is for the participants, if they have any doubts or questions, they can post their questions to the same website, and that can go or directly to the speakers, so that you can get your answers. But if you go through this portal, it'll, your questions will be shared with all the people participating, and they will also get the answers. So please do make your questions available to this organization, so that, and then all the question and answers will be shared with each participants directly from the organization from here. So I think extraordinary work. I don't know who did design this this souvenir. Somebody has really strained themselves to make it in a very short time, and it is available to all of you. So make the best use of this. Thank you.
Thank you, sir.
Yeah.
Sir, can you please share your
Thank
past
you.
experience,
So I've
whatever
been
you have,
asked
when you have
to.
around 40 years of experience? Can you please share it to our participants?
Yes, sir. You see, the first thing I would like to say that I have been an entrepreneur, and I also worked in Bharat Gold Mines as a maintenance engineer, where the structural steel and all these things were there every day. As a mechanical engineer, within 6 months of passing out, I faced this area, where I was directly put as a workshop in charge, and directly from college to the place where I could not even identify many things. So the idea of working with INSDAG from past 20 years, we have been propagating the steel. We have talked, and I think we have given lots of talks. And whenever INSDAG is there, especially in Instruct, it was a flagship program, and we attract lots of people all over India. Last time it was, I think the Navy also participated from Vizag, and rich knowledge was given to them. And INSDAC is a success story. They are always a success. And people like Mr. Ghosh and A.K. Samanta, I think it is extraordinary, and they are going strong. And we would like to work with them a lot. Especially here through this platform, I would like to appeal to INSDAC that we should make sure that, you see, knowledge is being given by the college. Lots of softwares are available, and the students are somehow getting the knowledge. On the drawing sheet, we will have to make some programs and taking all the 4 years of internship compulsory. This is, I think, with your industrial connection in Karnataka happening there, and let them work with their hands and let them feel the grease in their hands. Only then involved. A very big 80 meters hanger was being casted, and all the steel structures every day, without taking cognizance of that first day being the May Day, and in a hurry and completion, because MD has given a date. Here's best materials, everything was done as according to what. One thing was missing here is inspection. See, inspection, we have to climb up. Our boys and girls who are now in this, we have to put them working in height is the biggest challenge today. If these are the people going to work in the site, if we can give them this knowledge of how to work in the site, use of PPEs and everything, I think from the very first year, if we are going to expose them to this atmosphere, we will be doing a great, I think we will be contributing a lot of certified manpower, trained, certified manpower, which we have got. Manpower is ample. We have got technical support. We have got technical people. If we are going to put these people on the site and then train them, certify safety. Who was such a fat fellow, he could not climb about 20. है क्या? तो हाँ साहब हो गया है. In this structure where I am talking about, only one nut was just, one nut was there. They have not tightened these things. Nuts were not tightened. Everything was there, and the last span, the last three spans, suddenly the whole out, 300 people were there on the top, and all the top man hanger they went inside. Otherwise, the whole of that particular institution we would have lost. It happened somewhere in 1991, and it destroyed many industry, including me, because all my completion of all the aluminum structures were done there, but it was buried there. And like that, so many other institutions went off. And since it was 1st May, no one got compensation. I think this has to be conveyed. This has to be conveyed to all the industries. 1st of May is an important day. You do not get coverage by insurance at all. So, importance of safety and inspection has to be this opportunity to convey this, train this. I think every year we are taking out about 3,000 students from VTU. About 3,000 people, maybe it is both mechanical and civil. I think about 3,000 are coming. So this is only Karnataka. What about others? I think INSDAG can take this forward, and we can be the pioneers here. We with our institute to step in and do something along with the government of India to produce trained, certified manpower and bring our India to bigger heights. Thank you very much, all the dignitaries and all those people sitting far away from here, and all our people who are sitting in India and listening to this interesting session. I believe even in the last session, a lot of people are available listening to this thing. Thank you very much, INSDAG. Thank you from my bottom of my heart for giving such a wonderful program. Thank you very much. Thank you.
Thank you, Mohan Rao.
Thank you, sir. Thank you to all the staff and the technical people in VIVEKANANDA, and also JSS, who has also done a lot of work for this. Thank you.
Thank you very much, sir. Thank you for, we are very honored to have you here. So now I would like to request Srimati Indira Gopal Krishna, Vice Chairman GCVKIT, to say a few words about webinar. Hello.
Madam Indra Krishna. Somebody
Hello,
call her up.
Yeah, I will do so. She is joining, sir.
I have joined already. Okay. Can you hear?
Yes, madam.
Yes,
Yeah, madam. Chetana,
yes,
can you please continue?
Ma'am, I request Ms. Srimati Indira Gopal Krishna, Vice Chairman, GCVKIT, to say a few words about webinar. Over to Srimati Indira Gopal Krishna.
Thank you, Chetana. Good afternoon to one and all. Good evening, sorry. It was a great pleasure having all the guest lecturers here, and I am honored to attend this webinar. And I think with this webinar, and to all over India. Many participants came from different parts of the country, different parts of the world. I think a great effort by all the organizers. I really thank them, especially civil department and HOD and his colleagues. And it was very good. And we look forward to have more webinars like this. Thank you. I thank everybody who had come here to give the guest lectures. Thank you, sir.
Thank you, ma'am.
Thank you, madam.
I request Mr. A.K. Samanta, sir, GM INSDAG, to address the gathering.
Yeah, good afternoon.
Sir.
Good afternoon, sir.
Okay. Sir, exactly today I am away from Kolkata and attending another program. That's why you might be hearing that some little bit disturbance. So exactly I will not elaborate my speech. Only thing I want to tell that I thank a lot of thanks for all of you to make it happening. And today when Dr. Shashi Kumar suggested that it should be national webinar, then I really could not think it has gone international. Just now he has informed that we are organizing international program, not national program. Very good things. Okay, this is the exactly COVID has given us this opportunity to go online and you can reach to any corner of the world. So I think that is great achievement. But anyhow, everything started from somewhere. Always I remember who has started it, who is no other than Mr. Mohan Rao. He has started so many things. He has guided me for so many things, and I am really grateful, sir, for your this significant step that just when you have told me one program has to organize, I have put my all best possible effort to make it successful. Whatever topics Dr. Shashi Kumar suggested, I have tried to select the best speaker to the best of my knowledge. So I have nothing to say specially, but I must thank all of you, sir. It was a successful. I am very happy, and for that I thanks all of you. Thank you, sir.
Thank you, sir. I request Dr. Padmanabha S., Principal of VKIT, to say few words about the webinar. So over to Dr. Padmanabha.
Thank you, Chetana. Very good afternoon to all of you. At very first note, I would say a milestone as a webinar started for national level, reaching the international audience, participants. First, congratulations to the team and the people who have made this really a grand success is Mohan Rao, because the way he spoke as an entrepreneur, inspiring others, making the team to come together like INSDAG as well as SIDA. And the person who was faculty from JSS, helpful and channeler to reach the international Philippines, Afghanistan, various international countries, audiences. We'll have to say thanks to them. We are indebted. One critics I would like to place on record is, please, I request the organizers, collect the feedback form in the Google form so that it will go for on records. One. Second, wherever when you have done different topics of delivery, please make sure that participants will be involved in always right from point one to point end, so that a small questionnaire, a small test for them, that would help you as well as the presenter that the knowledge delivered is absorbed. So this is what I want to say, that please have a small test like thing in the webinars, so they'll not go in between, miss out many topics. Second point. Third, we would like to place on records, many of them have helped innumerable number of participants and also the people who have delivered, who are the plenary speakers, who are the experts, maybe from CDAG, maybe from INSDAG, maybe from entrepreneurs. Professor A.K. Samanta sir is sitting in another conference, international conference or national conference, trying to coordinate to both. I think A.K. Samanta should be a multitasker. Then Mohan Rao, I think, having 40 years of entrepreneurial experience, sharing his knowledge and helping all them to come together for this webinar. We thank all the organizers, and I think we'll have to say Dr. Shashi Kumar made a wonderful effort in making our Vivekananda Institute of Technology a global part for today's webinar. Thank you and good luck to all.
Thank you, sir. Thank you very much. Now I request.
Thank you, sir, and we will definitely consider your suggestions, sir.
Thank you.
In the future webinar, definitely we'll consider.
No, if it has not happened, I do not know if it has happened, it's good. If it has not happened, have this in record.
Yes, sir, definitely. We have not conducted any test kind of a thing.
At least Google form. Definitely, at least Google form you can. Sir. Yeah, please.
Yeah, Google
so
form we have.
Yeah, that is record.
Certificates, actually, sir, certificates will be issued based on
online.
The feedback taken from the Google form. Yes, sir, online.
Good.
Thank you so much, sir.
Thank you, sir.
Chaitanya,
Yes, sir. Now I would like to request our Chief Guest, Dr. N. Govindarajan, sir, Administrator cum Advisor of EKIT, to address the gathering. So,
sir, Dr. Govindarajan, sir.
hello, sir.
1 minute, I will just call him. Yeah, no, he has come. Yes.
Network.
Sir, Dr. Govindarajan, sir, can you please?
Can you hear me, all of you? Yeah, can you all hear me?
Yes, sir.
Can you hear me now?
Yes, sir.
Yes,
hello.
Sir. We can hear you, sir.
Good afternoon to each and every one of you. I am really delighted to be to preside over this valedictory function of this webinar. It is indeed a great effort by our Civil Engineering Department, Professor Shashi Kumar and his team. I really thank all the experts and speakers, their might and their great research find this, and this has spread all over the world. I was really astonished to know from Professor Shashi Kumar. This is not only from India, from all other countries and world over. Participants have. That shows the importance of this topic. It is a very great contributions are there. That is more great, eminent contributors, speakers. They have presented, and it is of great advantage to all the researchers to topics for their next approach to the newer problems. A country like India needs eminent structural engineers. Any project of national importance cannot be complete with by the structures. That is the topmost importance of the structural engineers. So, webinar and the topic that is chosen by team to organize webinar, and this has for the past 5 years, this is a great way and attracted so many participants world over. I'm really astonished. I thank all the organizers and the experts, and particularly I would like to thank our management, Janata Education Society, under which our institute, Vivekananda Institute of Technology, is running, and all our team organizing committee, Professor Shashi Kumar and his team, and our management, Indra Gopal Madam, our VKT chairman, Professor Padmanabha, principal, and our secretary sir, and all president sir, and all other management people who have really supported us in going through this webinar. I wish all the participants and many more such events will take place in our campus by our team of eminent organizers from the various departments. This civil engineering department has given has given lead in organizing such webinar. I really would like to congratulate each and every one of them and wish all the participants and the beneficiaries to get the true benefit and take this forward for the benefit of the nation and for the entire humankind. Thank you very much.
Thank you, sir. Thank you for your.
Thank you
very much. So now we are at the last session. We are having feedback by the students. We are having number of feedbacks. I can't read all the things. So we are just reading some of the feedbacks. So first is we are having Dr. S.P. Anchuri, architect and structural engineer in Hyderabad, has just given us a feedback like it was very professionally framed and organized workshop. These lecturers and its content not only gave class clear insight idea about use of structural steel as a unique option to RCC, but also helped students and faculty to take it up as core subject. Today, sustainable construction is the need of the hour, and VKIT along with the INSDAG has put good efforts bringing virtually all the stakeholders across the country successfully together for 5 days of webinars. So this it was a feedback given by. Next feedback comes from the Mark Louis Pyroment. So first and foremost, I'm honored to be a part of this event or webinar. I learned so much from different speakers. As a future engineer in Philippines, the knowledge I got from the 5-day webinar will be extremely useful in my future career. So now I'll take up another Garg, who is an ex-chief manager planning in HAL Lucknow. He gave us a feedback like it was a wonderful webinar. All speakers were well planned. Their speeches, benefits of steel structures over concrete were well explained. Speakers are masters of their field. Webinar will help us in the practice. Thanks to organizers and speakers. So, and we are having a lot of other feedbacks, but due to the time constraint, so I'm just reading out some of the feedbacks. So we are having another feedback, Melisa G. Velasi. So he just sent the feedback like, I appreciate those who organized this educational presentation. They were able to share their knowledge and it benefits our students, especially me. Thank you for taking your time to share it with us. A wonderful and excellent presentation made. Many thanks to the speakers. And another person whose name is Rinamel Lapitan. So he just gave us the feedback like, we really appreciate this webinar. Though there are some technical issues, but it absorbed quickly by the organizers, very informative, and it was discussed deeply by the presenters. The topic really catch the attention of the audience and it gave us knowledge which make the presenters excellent. We hope you conduct another webinar like this. And another person named Jamilian Robles. So he just gave us a feedback like this. Good day, I'm Jamilian Robles, a civil engineer student from Philippines. We learned a lot over the course of the 5-day webinar. There are some topics that we already studied at our university and some that we have only recently encountered. I'm pleased with the new knowledge that I have gained. Even though we encountered unavoidable technical issues, we were able to complete the program successfully. Well done. I hope you can do with such programs in the future. So these are some of the feedbacks. We are having lot of feedbacks, but it is difficult to tell all the feedbacks. So just in this feedback, we can conclude our program. So shall I conclude it?
Yeah, I thank once again all the people who has helped us, especially Engineer Mohan Rao sir and A.K. Samantha sir, and also all the speakers and all our management members and the principal, VKT principal and advisor, Dr. N. Govind Raju sir. I thank all the people. As Abhijit Ghosh sir is also there. I thank him for his wonderful lecture. And also being part until we complete the validatory function. Thank you so much, sir. I thank all of you once again. And I think we can conclude the valedictory function.
Thank you, sir.
Thank you so much,
you.
sir.
Thank you, Samantha, Mohan Rao, sir, and everyone. Good luck, Shashi Kumar.
Thank you, sir.
Okay, sir. Thank you.
Thank you.
Thank you.
Yes,
Thank you,
sir.
everybody.
It's my pleasure to give thanks for all the honorable guests present here. Thank you for everyone who attended the program. Thank you for every participant who participated in the program and made this program successful. So now we are just concluding the program. So thank you very much for everyone.
Thank you.
Thank you, sir.